All right, today we're going to go over linear programming. Linear programming is a real-world example of using systems of inequalities. Usually we use linear programming when wanting to maximize or minimize something. Most of the problems we're going to see is maximizing profit. Businesses use it to maximize profit or manufacturing. So we're going to go over some vocab as we go through the activity, and we're going to review graphing systems of inequalities from Algebra 1. When you are doing a linear programming problem, this system of inequalities is called constraints. Constraints is what's keeping us back from something. So it's our inequalities. We're going to go ahead and review graphing these. There's a couple different options that you can use to graph these. You can graph with the x and y intercepts, or you can solve for y and graph. In this case, this would be easy to graph with intercepts. In order to get the x-intercept, we plug in 0 for y. So that goes away, and x is 2. So on the x-axis, we're going to have a point at 2. To find the y-intercept, we plug in 0 for x. So that goes away, and y is 2. With 2 points, I can go ahead and draw my line. This is going to be a solid line since there's an equal sign there. It is solid because of this equal sign. If there was no equal sign there, it would be a dashed line. Now we need to figure out where our shaded area is, because with inequalities, you have to shade all of the solutions. Y is on the open side of this. So y is bigger than this, and y gets bigger as it goes up. So right now we have all of this area shaded. You want to shade lightly if you're going to shade, because the part, by the time we're done, we're going to have shaded 4 times, and it becomes a little messy on your paper. This next one is y is less than or equal to x. That's the linear parent function, so that should be another easy one to graph. 0, 0 would be my first point, and then it goes up 1 and over 1 with that slope of 1. Once you feel like you have enough points, then you can go ahead and just draw your line through that. Again, it would be a solid line since we've got an equal sign on that one as well. This one, the y is on the closed side of that x, so it's saying y is smaller. We know that y gets smaller as it goes down, so we have all of the ones below here. So we've lost this section right here. This is the part that we have so far. On the next 2 lines, we've got x is less than or equal to 4. If you remember from Algebra 1, when you had x equals a number, it is a vertical line. So we've got a vertical line at 4. And again, it's a solid line since it's got an equal sign underneath. X is less than or equal to 4 here, and we know that x gets smaller as it goes to the left. So we have now got this section right here. And the last one is y is greater than or equal to 0. Just as a reminder, when you have y equals a number, that is a horizontal line. There's not much to graphing this one since it would be the horizontal line on the x-axis and it's saying above. So our quadruple shaded area is this part right here. That's the part that we care about, the one where all of our solutions are. That shaded area is called the feasible region. So the feasible region is the area, the quadruple or triple shaded, depending on how many constraints you have. But the one where all of your solutions are found is called the feasible region. And these points that make out that feasible region are called the vertices. So in this case, that would have 4 of those vertices that create this shaded area. All right, every linear programming problem has an objective function as well. This is a function that represents what we are trying to maximize. So I told you most of the time it's profit that we're trying to maximize. That would be what the objective function is about, maximizing that profit. Once we have an objective function and vertices, we can find the maximum minimum by plugging that in. That's because you can only maximize or minimize at these corner points. So those points are really important, these vertices. You have to be able to get the vertices. And we've taught you guys how to do that with the calculator to find the intersection, or you can do it with a matrix, or you can do it with substitution or elimination. But you have to be able to get these corner points here that make the shape. All right, we're going to do a complete linear programming problem here. So they have given us our constraints. They have given us our objective function. The objective function is different. It's got the equal sign. The constraints are the inequalities. And then it's asking for your maximum minimum, and that's where you're going to maximize or minimize. So we're going to go ahead and graph these first. We've got 5y plus 4x is less than or equal to 40. Now I'm going to go ahead and do one with the intercepts, and then I'll do one by solving for y. So if I'm graphing with my intercepts, I plug in 0 for the y, and I get 40 equals 4x. I divide 40 by 4, and that's 10, so I know my x-intercept is 10. To get the y-intercept, I plug in 0 for the x, so that's going to go away, and we get 40 is equal to 5y. I divide by 5, so that's 8. So I'm going to go to 8 on the y. And then you can just make the line through those 2 points. We'll go ahead and solve for y just so that you guys can see that as well. If you are solving for y with an inequality, you're going to do basically the same thing you would if there was an equal sign there. The only difference happens if you divide by a negative, you've got to flip that sign. So I subtract the 4x to get it to the other side. And then I divide by 5. Y is less than or equal to negative 4/5 x plus 8. There's our y-intercept of 8. We already knew that. And then we are going down 4 and to the right 5. And down 4 and to the right 5. And you'll land right on top of that other one, the x-intercept. This one's got an equal sign, so I'm going to go ahead and make a solid line through those points. The y, again, is on the closed side of this, so it is less than this line. We know that y gets smaller as it goes down, so right now we're talking about this triangle area right here. We're going to go ahead and do the same thing for the second one. We subtract the 2x and divide by 5. So our y-intercept is 4, and our slope is negative 2/5, so we go down 2 and to the right 5, and down 2 and to the right 5. Again, it's a solid line, so we'll go ahead and connect our points here at this part. The y is on the open side of this inequality here. So it tells us that y is bigger than this line. So we would be shading above that line. So right now we're talking about this middle section. We've lost this bottom part. We are now ready to graph our other two. We said y equals the number is a horizontal line. So I'm going to have a horizontal line at 6. And it too is solid. It says y is less than 6. So we want to shade below because y gets smaller as it goes down. So we've now lost this little triangle. We're talking about this section in the middle here. And then our last one, x is greater than or equal to 1. That's a vertical line at 1. And x gets bigger as it goes to the right, and that's what it's saying here. X is bigger than 1. All of our x values that are bigger than 1 are to the right. So our feasible region is this middle part. There's our feasible region. Again, with the vocabulary, these are the constraints. This shaded area that has all of our solutions is the feasible region. And what we need next is these, or are these vertices right here. We've got 1, 2, 3, and 4 of them. Some of them are going to be easier than others to find. For example, that one right there, that should be really easy. We found that was the x-intercept at 10, 0. So we've got one vertex so far. Now we need to find the other ones. Another easy one is where our horizontal and our vertical line intersect. We know that the x value there is 1 and the y value is 6. So we also know that one. Now to find the other two. Here, we're finding the intersection between that y equals 6 line and our top one right here. So you could use substitution and plug that 6 in for y and solve for the x. That's a possibility. You can use your calculator. So I've gone ahead and graphed our lines here. I didn't graph our vertical line since the calculator does not graph a vertical line, but that's the intersection we're trying to find right there. So we hit second trace intersect. We move over towards that intersection, hit enter. Now it bounced over to the other line. We do not want the intersection between that one. So I'm going to go to the y equals 6 line and then hit enter. And then enter for the guess. And there it is at 2.56. Now for our last one, this one right here, is the intersection between our vertical line and then our lower one right here. We're looking for that intersection. We can't graph a vertical line on the calculator, but we do know that the x value there is 1. So again, you can use substitution and plug in 1 right here to find that value. Or you can even go to our table of values. We know that the x value is 1. That's the higher 1 value, so that's going to be the one up here. We need this lower one. So there is the 3.6. So our vertex here is 1 and 3.6. All right, now that we have our vertices, it is time to figure out which one is going to maximize or minimize our problem. We do that by using the objective function. Remember, ordered pairs are x comma y, so you've got an x and a y to plug in here so that you can find what the value is. So you would take each one of these and plug them in. You're going to do the same thing for each point so that you can find which one has the maximum value and which one has the minimum value. So our first one here gives us a value of 15.2. Our second one gives us a value of 32, 20, and 80. Now you're going to look at these values and see which one is the biggest and which one is the smallest. This is our highest value, so this is where we're going to maximize. This gives us the smallest value, so this is where we're going to minimize. So if they're asking you, for example, how many you are going to build or how much you're going to need, then that would be this part, and what the profit would be, then that would be this answer. So you want to be careful when you're answering the question that they're asking. The maximum amount is going to be 80, and the minimum amount is going to be 15.2. And this occurs at 10, 0. And this one occurs at 1, 3.6.